Evaluate a possible solution to, all right, let's see what we got here. F of x equals x plus, times square root of quantity, x plus 2. Okay. So there's this thing in mathematics you'll hear a lot of times where first time you see a trick, it's a trick. The second time you see it, it's a technique. And that's kind of true here. I really don't like that phrase though, because it makes it sound like math is just a whole series of guess and checks and know this obscure rule, know that obscure rule. And it kind of is. But that's kind of what we see here. So when you see something along the lines where you have a x plus something under the radical, you say u equals x plus 2. Not always x plus 2. If it's something else, you use the other number. But then you rearrange this to say that u minus 2 equals x. Take the derivative of both sides. Du equals dx. And this is how you do the substitution. So then we'll have integral x u minus 2 times square root of u du. Perfect. So now we can distribute. Before we couldn't, you can't distribute the, okay, we'll go through it later. This is the way we want to do it. So square root of u is the same as, change to blue, u to the 1/2. This will be u of 2 over 2, which is the same as u to the first. So we'll have u to the 3/2 minus 2u to the 1/2. Still have the little integral, still have the du. And now we can use the power rule. So u to the 5/2 times 2/5 minus 2u to the 3/2 times 2/3. And then there's a plus c involved. So then we'll do 2/5 u to the 5/2 minus 4. 4/3 u to the 2/3. 3/2 plus c. And that's the answer. It's interesting. They don't have a plus c here, but that's because they say a possible solution. And so then here we have 2/5 x plus 2 5/2 minus 4/3 x plus 2. Yep, it's this one right here. Whoop. Okay. Now backtracking slightly, we have one intuitive thing that you would think to do would just be to distribute the x, which is wrong. Well, you can do it. So it just won't be useful. So you could be like, all right, here. So let's say x squared to the square root is the same as x. Then we have x plus 2 over here. And so we can say, well, this is kind of like x cubed plus 2x squared square rooted dx. And this is totally true. But then you might be like, well, then this equals x to the 3/2 plus 2x to the 1/2. Does not equal. Cannot be done. But if we went down this terrible road of perdition, we will get x to the, 5/2? 2/5 plus 2x 3/2 times 2/3, which would be 2/5 x to the 5/2 plus 4/3 x to the 3/2, which you see is similar to what we had before, but we lose that inner variable, the x plus 2. And that is why we can't go down this path. All right, and that is the solution to evaluate x times square root of x plus 2.